For this video, I'm going to be showing you how to solve for all the rational roots. I'll go through all the steps with Descartes' rule, finding all the possibles, and then actually finding the roots. So to start with, we're going to figure out how many total roots we can expect, and that is based on the leading exponent, or in this case, the actually highest exponent, which in this case is a 3. So I should expect 3 roots. I can't have more than 3, I could have less. Okay, so for the positives, I just want to look at the original equation and find out how many times the sign has changed or how many times the operation changed. And I started positive, stayed positive, but then I jumped to negative, so that would be 1 change and I stayed negative. So that's 1 positive. Normally I would subtract by 2, but I want to subtract by 2 until I get to 1 or 0, and I'm already at 1, so I'm not going to subtract anything. To get the negatives, I'm going to change the odd signs to operations to negative, the odd exponents operations to negative, and then I'm going to look for the change. So x cubed, so this guy's going to be changed and this guy's going to be changed. So I'm going to call that negative x cubed. I'm not going to change the even exponent. I'm going to change that to plus 5x because it's odd. And then I don't change the constant because there's no value with it. All right, now I'm going to look for the change in the operation here. So I started with the first term, and there's a negative to a positive, so that's 1. I stayed positive, then I went back to negative, so there's 2 changes. Okay, and this is where I would subtract 2. So if I subtract 2 from 2, I get 0. Okay, so I'm going to say 2 or 0 positives. From this point, I'm going to make the chart. So I have positives, negatives, and I'm going to remember I need 3 in all. Okay, so if I positives, I'm always going to have 1 positive. That's not going to change. But I could have 2 negatives, and if I have 1 positive and 2 negatives, that's going to leave me with 0 to get 3, because 1 plus 2 is 3. All right, then the other option for positives is still 1, but the options for negative would be I could get 0 negatives. So if I have 1 positive and 0 negatives, I still have 2 left over, which would mean that I could have possibly 2 imaginary numbers. So when I do the synthetic division, I either have 2 negatives and 1 positive, or I have 1 positive and then I'd have 2 imaginary numbers and no negatives. So that's what I'm going to do now. I'm going to figure out the possibles. The possibles deal with the p over the q. Okay, so the p is the last term and the q is the first term. So in this case, the p is 6 and the q is 1, which makes it kind of easier. So I'm going to write the factors of both of those. It's always going to be a plus minus, so the factors of 6 are 1, 2, 3, and 6, and the factors of 1 are just 1. So now what I would do to list all the possibles, I'm going to list all the numerators over the denominators each separately. And since there's only a denominator of 1, my possibles are just going to be 1, 2, 3, and 6. Again, if there was another denominator, I would list all those numbers over that denominator also. So right now I have plus minus 1, 2, 3, and 6, which means I have 8 different options. Now I use those options to do my synthetic division. So my synthetic division, I don't need a placeholder because every exponent is covered. So I'm going to write down 2, negative 5, negative 6. I always bring down the first term. All right, I'm going to try 1, 2, 3, or 6 as one of my options. I'm going to start at the beginning and just try 1. So 1 times 1 is 1, 3, 3, negative 2, oops, negative 2, that's going to give me a negative 8. That's not a 0, so this is not a good answer. So I'm going to erase that option and try something else because that one is not a keeper. I need to get 0 at the end to make it a good value. All right, so I'm going to try negative 1 instead of 1 because that's also an option. So I bring down the 1, multiply, I get negative 1, I add, I multiply, I add, I multiply, and look, I got a good answer. So one of my final answers is going to be negative 1 because that works. There's a 0 here. So now what I can do is either I can go another step and go down again and try a different value, or I can take this problem right here and write it out and factor it, which I'm going to do because I know I can factor that guy. All right, so when I do this, remember, This value is my remainder. This would be my constant. This would be my x. This would be my x squared. So if you start at the end, remainder, constant, x, x squared. All right, so I'm going to write -6, keep going, that's going to be an x, and then it's positive, and then I'm going to say x squared is the first term. All right, now I'm going to factor that, so I just want, this is equal to 0. So I want two numbers that multiply to give me a -6, and add to give me a +1. So I know that's x and that's x. So I know it's going to be 3 and 2 multiply to give me 6, and one of them needs to be negative and one needs to be positive. I need more positive, so that's going to be my positive. All right, so those are my factors, and now my next step is I want to solve those. So if I solve those and set them equal to 0, one answer would be -3, and the other answer would be a +2. Those are my answers. I'm just going to write them in there. I didn't write them in any order. I could write them in from smallest to largest. I did not. So those are my final roots. Okay, so those are my 3 answers, and that is how I would solve that.